Good morning, children. So today we are going to begin exercise 8.1, continuation of the previous class. Question number 6. So it is given that diagonal AC of a parallelogram ABCD bisects angle A. So to prove, number 1, AC bisects angle C. Number 2, ABCD is a rhombus. So in the given part, we will see that diagonal AC of a parallelogram bisects angle A. So that is the diagonal AC of this parallelogram ABCD bisects angle A. That means dividing angle A into equal parts. So these two angles will be equal. Let us name these angles as 1 and 2. And say let this be 3 and 4. You are to prove AC bisects angle C. That means to make AC bisects angle C, you are to prove that the diagonal AC should divide angle C into two equal measures. That is, angle 3 equals to angle 4. When we prove that angle 3 equals to angle 4, then AC will bisect angle C. Then the second one, ABCD is a rhombus. So to make the parallelogram into a rhombus, you will have to show all the four sides equal, because rhombus is a quadrilateral having all the four sides equal. So now the first one. So here they have given that the diagonal AC bisects angle A. So this diagonal AC divides the whole angle A into two equal parts, which means angle 1 is equal to angle 2. Now you will prove AC bisects angle C. So that means to prove that AC will divide angle C into two equal parts, in that case you will say that the diagonal AC bisects angle C. You can do it in two ways. One is by making the triangles congruent, taking the triangle ABC and taking the triangle ABC. Or else now you can do in a shortcut way, because the given figure ABCD is a parallelogram, which means here DC is parallel to AB. So here DC is parallel to AB. So it is AB, it is CD. Now let us take, say this two is joined, AC is joined. So here angle 3, this one is angle 2. So here as this given figure ABCD is a parallelogram, that is why DC is parallel to AB, also BC is parallel to AB. Now as DC is parallel to AB, that is why angle 2 equals to angle 3. Angle 2 is equal to angle 3. This is due to the alternate angles. Secondly, again we have got that AD is parallel to BC. So here AD is parallel to BC. So you have joined AC. So it is A and C. So angle 1 and 4. So here angle 1 equals to angle 4, because they form a pair of alternate angles, because here DC is parallel to BC. So this AD and BC are parallel lines. So this is the shortcut way, or else you can make the triangles ABC congruent to triangle ABC. In that case, these two angles also will be equal by simplicity. Hence, AC bisects angle C. So you take the first one, so it is proof. Let us take number 1. So it is given that AC bisects angle A. So this line segment AC divides the measured angle A into two equal measurements. Angle 1 is equal to angle 2. So it is given bisects. So angle 1 is equal to angle 2. Since, so here AC bisects angle A. Next here, AB is parallel to BC, BC is parallel to AD, because ABCD is a parallelogram. That is why the opposite sides are parallel as well as equal. So you get that AB is parallel to DC. If you get that this line is parallel to DC, in that case angle 2 equals to angle 3 because they will form a pair of alternate angles. So here angle 2 equals to angle 3. So it is AB is parallel to DC and then they form a pair of alternate angles. So it is alternate angles. So let us take this as equation 1. This is equation number 2. Again, here you have seen that AD is parallel to DC. So these two opposite pair of sides are also parallel. So here you will get that since AD is parallel to BC, you will get this angle and this angle will be equal. That is angle 1 equals to angle 4. So these two angles also will be equal because they form a pair of alternate angles. So here angle 1 is equal to angle 4. So it is since here AD is parallel to BC, it is alternate angles. Alternate angles. Let us take this as equation number 2. Now you take from 1. So you take from 1. So you got angle 1 is equal to angle 2. So from this first one. So you have got from equation 1, equation number 1. So you got that angle 1 is equal to angle 2. So now from this you have got that angle 1 equals to angle 4. So these two angles are equal. So now angle 1 is replaced by angle 4 equals to angle 2 equals to angle 3. So now angle 2 is replaced by angle 3. So here angle 3. So this one you got from equation so 2 and 3. So in place of 1 you have written 4 because 1 equals to 4. Then here so in place of 2 you have wrote angle 3. So from equation 2 and equation number 3. So from 2 and 3 you have got. Now you see angle 4 is equal to angle 3. So now these two angles are equal, which means that the diagonal AC bisects angle C. Why? Because these two measurements are equal. So you have proved angle 3 equals to angle 4, which means that the diagonal AC bisects angle C. So therefore AC bisects angle C. So you have proved the first one. So how you have proved that? They have given that the diagonal AC bisects angle A. So here 1 and 2 equal. 1 and 2 is equal since AC bisects angle A. Next, the given figure ABCD is a parallelogram, which means the opposite pair of sides are parallel. So here, if you take that AB is parallel to DC, in that case, angle 2 equals to angle 3. They form a pair of alternate angles. So here 2 and 3 is equal because AB is parallel to DC and they form a pair of alternate angles. So this is taken as equation number 2. Next here AD is parallel to BC. So you got angle 1 equals to angle 4 because AD is parallel to BC and then they form a pair of alternate angles. Now from 1, equation number 1, so you got 1 equals to 2. Now angle 1 is replaced by 4 because they are now equal. So in place of 1, so you wrote angle 4. Then in place of angle 2, you wrote angle 3. So you got this one from 2 and 3. So now as here these two angles are equal. So angle 4 and 3 are equal, which means the diagonal AC bisects angle C, dividing angle C into two equal measurements. So thus AC bisects angle C. Now coming to the second one, ABCD is a rhombus. So to make the given parallelogram into a rhombus, you have to make all the four sides equal. Now the second one, so ABCD is a rhombus. So the second proof. So now the proof comes. Proof of this second one. So to make the given parallelogram, now here ABCD is given as a means parallelogram. You are to make this parallelogram into a rhombus, making the four sides equal. AB equals to BC equals to CD equals to DA. So now let us see. Already the given figure is a parallelogram, that means the opposite pair of sides are equal. So here you can take that AB equals to DC, so these two opposite pair of sides equal. So AB equals to DC, and then here BC equals to AD. So BC equals to AD. Reason is, since opposite pair of sides, opposite sides of a parallelogram are equal. So are equal. Let us take this as say equation say A. You can give as A x y also. Now let us give as x because there is A. Now next one, you have seen that here now this is a parallelogram, and from the property of the parallelogram, so you know that opposite angles of a means parallelogram are equal. So here now you take angle A is equal to angle C, or here B equals to D. So we will take A and C. So here angle A equals to angle C. So this angle and this angle is equal, since opposite angles of a parallelogram, opposite angles of a parallelogram are equal. Now you see, diagonal AC bisects angle A. This one was given in the question, and now in the first proof you have proved that AC bisected means angle C. That means these two measurements are equal, 3 and 4, and here 1 and 2 are equal. So now we can take this half. So half of angle A equals to half of angle C. That means dividing by 2 on both sides. So now you see, so half of angle A. So you take the half. Each of the angles as they are equal. So 1 and 2 half of A, then 3 and 4 half of C, because their measurements are equal. So 3 equals to 4 because AC bisects angle C. So thus 3 and 4 each of half of angle C, and here angle 1 equals to angle 2. So each of the angles, that is 1 and 2 half of A. So now half of A you can write say angle 2. So here angle 2 equals to half of angle C. So half of C. So these two are half of C because they are equal. So you take half of this angle, you can write angle 4. So here angle 4. Since AC bisects angle A and angle C, because AC divides angle A into two equal halves. AC divides angle C into two equal halves. That is why each of the angle, that is half of A, means 1 or 2, or half of angle C means angle 3 or angle 4. So in place of half of angle A, you have written angle 2, and in place of half of angle C, you have written angle 4, because AC bisects angle A as well as angle C. Now from the means triangle property, that is the isosceles triangle property which we have proved in the triangle. So here you see this is a triangle. So ABC, this is a triangle. So in this triangle ABC, so you got that angle 2 is equal to angle 4. So this is a triangle say. So the triangle is like this. So now here angle 2 and angle 4 are means equal. So you have here proved it. That is why, since the opposite angles are equal, that is why here opposite sides are also means equal. So the side opposite to, so the side AB opposite to angle 4. That is why you have taken AB, and the side BC opposite to angle 2. So that is why, as the opposite angles are equal, that is why here opposite sides are also equal. That is why now you take the side opposite to angle 2. So the triangle is ABC. So the side opposite to angle 2. So that is BC. So you take here BC equals to the side opposite to angle 4. So angle 4. So the side is AB. So this is due to since you have got it that sides opposite to equal angles. Sides opposite to equal angles are equal. So are equal. So you have proof in the triangle chapter. So now, since the opposite angles of the triangle ABC are given as equal, that is why their opposite sides are also equal. That is why the side opposite to angle 2 is BC, and the side opposite to angle 4 is AB. So you got it. Let us put this as, say, equation number y. Now you compare this x and y. This is the equation x and this is equation number y. So from comparing, so from x and y, we get. So now you see here, BC equals to AB. Let us take, say, BC equals to AB. Now you see AB equals to DC. So the measurement of BC equals to AB. Also here AB equals to DC. So here you can write AB equals to DC. Then here you see BC equals to AD. So here BC equals to AD. So that means here you have got that all the four sides are equal. So you see BC equals to AD. This is from y, equation number y. So BC equals to AD. Then, but it is given that BC equals to AD. So here BC equals to AD. Also it is given that AB equals to DC. So AB equals to DC. That means all the four sides are equal. So AB equals to BC equals to CD equals to DA. That means you got all the four sides equal. So therefore, parallelogram ABCD is a rhombus. So because you have proved the four sides equal. So here what you did in the second part, you have taken the opposite sides equal, because here they have given that the given figure ABCD is a means parallelogram. So here the opposite sides are equal. So you took this as, say, like equation x. Then next you have got that angle A is equal to angle C. Opposite angles of a parallelogram are equal. So you have taken. Now this diagonal AC bisect angle A as well as means angle C. That is why each of the angle 1 and 2, half of A, here each of the angle, that is 3 and 4, half of C. That is why half of A, so you wrote angle 2. Half of C, so you wrote angle 4. Now in the triangle ABC, you got opposite angles are equal. So you have seen that the opposite angles are equal. That is why from the theorem you have got that if the opposite angles of a triangle are equal, it means that their opposite sides are also equal. So the side opposite to angle 2 is BC. So you got BC. The side opposite to angle 4 is AB. So you got A. Now you have taken this as equation number y. Now you compare equation x and y. So from y you have got BC equals to AB. So BC equals to AB. But given that AB equals to DC. So AB equals to DC. So AB equals to DC. Then BC equals to, so BC equals to AD. So here AD. So you got all the four sides equal. Thus the given parallelogram is a rhombus. So it is. Let us take question number 7. Given, so ABCD is a rhombus. Now to prove number 1, diagonal AC bisects angle A as well as angle C. Number 2, diagonal BD bisects angle B as well as angle D. So here is given that ABCD is a rhombus. So as you know, rhombus has got all the four sides equal. Assuming that all the four sides are equal. So you assume that all the four sides are equal because they have given that the given figure is a rhombus. So A, B, C, D. Now they have told you to prove that the diagonal AC bisects angle A as well as angle C. So you are to join the diagonal AC because they have mentioned here that the diagonal AC should bisect angle A as well as angle C. Secondly, you will come to BD. So let me first join just AC so as to make it clear. So then the second case you will join BD also. So now to make the diagonal AC bisects angle A as well as angle C, what you will do is you can take their alternate angles also, or you can make the triangles congruent. Here you will make the triangles congruent so that the figure will, so that the proof comes means all at once. That is why now let us take the triangle say ABC, triangle ABC, and then you have taken the triangle ADC. So ADC. So because here AB and AD are equal, that is why ABC means ADC because their sides are all equal. So now in these two triangles you have got, so here AB equals to AD. So here AB equals to AD. So you got it because they are the sides of a rhombus. Because you know that rhombus has got all the four sides equal. So they are the sides of a rhombus. So this is the first one. Then in the next one, BC equals to DC. So BC equals to DC. So BC equals to DC. They are the sides of a rhombus because in the rhombus all the four sides are equal. Then one more point, that is the simple one. In both the triangle, the side AC is the common side. So you got AC equals to AC. So it is the common side. So you got the three conditions. So therefore, triangle ABC congruent to triangle ADC by side. So you have made the triangle congruent by SSS. Therefore, the corresponding angles of A are equal. That is angle BAC. So BAC is equal to angle DAC. So DAC. So these two angles are now equal because we made the two triangles congruent by simplicity. Again you see angle BCA. So BCA, this angle equals to angle DCA. So DCA. So these two angles are also equal. So you have made these two angles equal also by simplicity, as these two triangles are congruent. Thus AC bisects angle A because these two angles are now equal by simplicity. Similarly, AC bisects angle C because these two angles are also equal by simplicity. So now let us take the first proof of 1. So now diagonal AC bisects angle A as well as angle C. So here the diagonal AC should divide angle A, angle C into equal measures. So now in triangle say ABC, so ABC, and triangle ADC because AB and AD are equal. So ADC. So now AB equals to AD. AD, yes, sides of the rhombus because here the figure is a rhombus where all the sides are equal. Next you got BC equals to DC. So BC equals to DC. So BC equals to DC, the same reason for these two, the sides of a rhombus. Sides of a rhombus. Rhombus. Then you got one more. So here the side AC is the common side. So AC equals to AC. This is the common side. Common side. Common side. So you have got the three conditions. Therefore, triangle ABC, triangle ABC congruents to triangle ADC. So ADC by SSS. So side, side, side. So by SSS the triangles are congruent. So as the two triangles are congruent, so their corresponding angles are also equal. Now you can see from this angle, therefore angle BAC equals to angle DAC or angle DCA equals to angle DCA. So the two triangles are congruent, so their corresponding angles are also equal. So therefore angle BAC is equal to angle DAC. So DAC, you have got it by simplicity. Corresponding parts of congruent triangles. Then angle BCA is equal to angle DCA. So DCA, this is also by simplicity. Now let us see. So BAC, this angle equals to angle DAC. So DAC, so these two angles are now equal. That means AC bisects angle A. Again, angle BCA. So BCA. So this angle equals to angle DCA. So these two angles are also equal by simplicity. Thus AC bisects angle C. That means AC bisects angle A as well as angle C. So you have got the first one. Therefore AC bisects angle A as well as angle C. Now they have said the second one. So similarly you can do the next one, that is diagonal BD. So now you see, supposing I have now removed this AC, now you join this BD. So diagonal BD bisects angle B as well as angle D. So in the same way as you did the first one, so you will take the triangle like say in the triangle DAD and DCD, because the sides are equal, adjacent sides are equal, because the figure is a rhombus. So that is why in the triangle DAB and the triangle DCB, so these two sides are equal. So they are the sides of a rhombus. Next here AB and BC are equal, same thing, because the figure is a rhombus. Then we have got the common side BD for both the triangles. So the two triangles are congruent by side, side, side. Therefore, these two angles will be equal by CPCD. Thus, BD bisects angle D. Similarly, you will get these two angles also will be means equal by CPCD. Thus, BD bisects angle B. Hence, the diagonal BD will bisect angle B as well as angle D. You will take the triangle DAB and you take the triangle DCB. Now comes the proof 2. So in triangle, say DAB, so DAB and triangle DCB, so DCB. So here DA equals to DC, so DA equals to DC. So these two sides are equal because the figure is a rhombus, and you know that in a rhombus all the sides are equal. So then AB equals to CB, so AB equals to CB. So here AB is equal to CB, so it's CB. So the same reason, the sides of a rhombus, are equal. Rhombus. So now then, for both the triangle, you got the common side DB. So here DB equals to DB is the common side. So you got the three conditions. Therefore, triangle DAB congruent to triangle DCB by side, side, side. So by SSS congruence, the triangles are congruent. Therefore, you will get that angle ADB. So they are corresponding. So angle ADB is equal to angle CDB. So CDB, this is by CPCD. Now you see angle ADB, this part equals to angle CDB. So CDB. So these two measurements are equal. That is why BD bisects angle D, and angle ABD is equal to angle CBD. So CBD by CPCD. Corresponding parts of congruent triangles. So here ABD, so this angle equals to angle CBD. So these two angles are also equal. Thus, DB bisects angle B and angle D as well. Thus, so from these two, you have got that diagonal BD bisects angle D, diagonal BD bisects angle B. Thus, the diagonal BD bisects angle B as well as angle D. So it is proved. Let us take question number 8. Given ABCD is a rectangle in which diagonal AC bisects angle A as well as angle C. Number 1. So to prove 1. ABCD is a square. ABCD is a square. Number 2. Here diagonal BD bisects angle B as well as angle D. So here the given figure is a rectangle. So here we have given that the diagonal AC bisects angle A as well as angle C. You are to make the first proof ABCD is a square. So they have given that the given figure is a rectangle, and this rectangle you are to convert it into a square where all the four sides must be equal and all the angles must be, that means 90 degree. Then the second proof, diagonal BD bisects angle B as well as angle D. So now here we will draw the figure like a square. And you just, because they have given the diagonal AC, you have just joined it because this one is given. You have to prove the diagonal BD. So this diagonal BD we will just make it dotting. This is true construction. Now here the opposite sides are equal because the figure is a rectangle. You will assume that this given figure is a rectangle and you are to convert this rectangle ABCD into a square. So where you will make all the sides equal and all the angles 90 degree. But here the 90 degree concept doesn't come because already they have given that the given figure is a rectangle, which means opposite sides are equal, and here each of the angles will be 90 degrees. So here all are now, that means 90 degree because the figure is a rectangle. So you not need to make 90 degree, you are just to make all the four sides equal. Now here AC bisects angle C and A. So you take this is 1, it will be angle 2, angle 3, and here angle 4. Let us take, say now here ABCD is a square. So to make the given figure square, just you make the four sides equal because already the given figure is a rectangle where you got all the four sides, you got the opposite sides equal and all the angles are, that means 90 degrees. So the concept of 90 degree does not come because that one is given, because the figure is a rectangle. Just to make all the four sides equal and making the four sides equal, the given figure rectangle becomes a square. Now here comes construction. So you have joined BD. So here BD is not given, they have given AC. So here that is why you have joined the diagonal BD, because diagonal BD should bisect angle B as well as angle D. So here construction BD is joined. BD is joined. So now comes the proof. Number 1. So first of all, the given figure is a rectangle. So the opposite sides are equal. So here AB equals to DC, then BC equals to AD. So AB equals to DC and BC equals to AD, since they are the opposite sides of rectangle. Opposite sides of a rectangle. Let us take this as 1. So combining these two, this will be taken as the first equation. Now you see here the diagonal AC bisects angle A as well as angle C. That means each of the angle, that will be half of A, that is 1 and 2 half of angle A, 3 and 4 that will be half of angle C, because AC divides angle A, angle C into two equal parts, making it half. So 1 and 2 will be half of A, 3 and 4 half of C. So now here angle A is equal to angle C because they are all 90 degree, because the given figure is a rectangle. Since ABCD is a rectangle, so 90 degree. Now making it half, so half of angle A is equal to half of angle C. So now half of A, so half of each of the angle 1 and 2, half of A, so you can take half of A means you can take angle say 2, angle 2. So you have taken this 2. Then half of C, you can take 4. So angle 4. Why? Since AC bisects, that means AC divides angle A, angle C into equal parts. So bisects angle A as well as angle C. Now in the triangle ABC, so in the triangle ABC, so you both the opposite angles are equal. So these two angles are equal. So that is why here opposite sides also will be equal. So therefore the side opposite to angle 2. So this one is angle 2. Opposite side is BC. So you will get BC. Then the side opposite to angle 4. So this one is angle 4. Opposite side is AB. So you have got AB. So the sides opposite to equal angles are equal. So since sides opposite to equal angles, the sides opposite to equal angles. Let us take this one as equation number 2. Now you compare this first equation, taking this 2 as means first equation and this is the second equation. So comparing these two equations, you will get so from equation 1 and 2, so from first and second equation you get. Now you see here, so here BC equals to AB. Let us take, okay, BC equals to AB. So you took it from 2. Then now you go to the first equation, so BC. So BC equals to AD also. So BC equals to AD also. So BC equals to AD. BC equals to AD. But BC equals to AD. So BC equals to AD. Also AB equals to DC. So AB equals to DC. So you got all the four sides equal. So AB equals to BC equals to CD equals to DL. So you got all the four sides equal. Thus, and here all the angles already they are given as that means 90 degree, because the given figure is a, that means rectangle. So that is why therefore rectangle ABCD is a square. So the first part is proved. Now you come to the diagonal BD bisects angle B as well as angle D. Okay, for your that means understanding, let me now rub this one so that will be more clear. So let me just rub it. Now you take it. Now you see the drawing comes. So the given figure becomes a square where all the four sides now has become equal because we have made it a square now. So now you have to prove that diagonal BD should bisect angle B, making these two parts equal. Diagonal BD should bisect angle B, making each of this part equal. So that means to make each of these parts equal, you are to make these two triangles congruent. How? You take the triangle DAB and take DCB. So DA you took with DC. So DAB and you took DCB because they are now equal. So in triangle DAB, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24, 25, 26, 27, 28, 29, 30, 31, 32, 33, 34, 35, 36, 37, 38, 39, 40, 41, 42, 43, 44, 45, 46, 47, 48, 49, 50, 51, 52, 53, 54, 55, 56, 57, 58, 59, 60, 61, 62, 63, 64, 65, 66, 67, 68, 69, 70, 71, 72, 73, 74, 75, 76, 77, 78, 79, 80, 81, 82, 83, 84, 85, 86, 87, 88, 89, 90, 91, 92, 93, 94, 95, 96, 97, 98, 99, 100, 101, 102, 103, 104, 105, 106, 107, 108, 109, 110, 111, 112, 113, 114, 115, 116, 117, 118, 119, 120 Now it is 2. In triangle DAB and triangle DCB. So these two triangles. So DA equals to DC. So DA equals to DC. DA and DC are equal because now here ABCD is a square. Already you have proved in the first part. So here all the sides will be now equal. That is why DA and DC are now equal. Then AB equals to CB. So AB equals to CB. So AB and CB are. So since ABCD is a square. Since ABCD is a square, because in a square all the four sides are equal. Then you have got the common side in both the triangles, that is DB. So DB is the common side for both the triangles. So here DB equals to DB. This is the common side. So you got the three condition. The two triangles are congruent. Therefore, triangle DAB congruent to triangle DCB by side. So side. Therefore, angle ADB. So ADB. So it does same way. So you take CDB. So angle CDB. So ADB. So this angle equals angle CDD. So these two angles are equal by CPCD. So CPCD. It means that BD bisects angle B and angle ABD. So angle ABD is equal to angle CBD. So angle CBD. This is also by CPCD. So ABD. So ABD. So you got this angle equals to angle CBD. So CBD. So you got this. So these two angles are also equal. Thus BD bisects angle B. Thus BD bisects angle B as well as angle D. So it is proved. So in the first part, let me just tell you, they have given that the given figure is a means rectangle where the opposite sides are equal and each of the angles 90 degree. So to make the given rectangle into a square, you have to make only the four sides equal, because you did not make here 90 degree, because 90 degree is given, because the given figure is a rectangle. That is why you have just made all the four sides equal, and then making the four sides equal, the given rectangle ABCD is a square. Then by joining this BD, you took these two triangles. So you have made these two triangles congruent, and then you have got their adjacent angles equal. So these are the adjacent. So if these two angles are equal and then these two angles are equal by CPCD, thus BD will bisect angle B as well as angle D. With this, we have come to the end of today's class. Thank you.